Today we're going to review. For the on activities 9, 10, 11. It has a no calculator portion and a calculator portion. The non-calculator portion is just the top half of this paper, and it asks the exact same questions that you see here, just with a different function. So the idea is that you're going to be prompted to answer the question so that you can draw a nice graph of this factored polynomial. So the polynomial will be factored out. The degree, you're asked about the degree because you need that to figure out the end behavior. So this is x, and then we would have x squared, and then we would also have x another x squared. So if we multiplied x times x squared times x squared, we would get x to the 5th. So that would be the highest power. So the degree is 5. Maximum number of turning points, this might also help you draw your graph. That would be 1 less, which is 4. The y-intercept, if you make all the x's 0, so 0 times 0 minus 1 quantity squared times 0 plus 4 quantity squared. Remember, this is the non-calculator part. Only reminding you in case you're planning on using your calculator for that. This is basically 0 times whatever. Who cares what this is? We're multiplying 0 times a whole bunch of stuff. So the y-intercept is 0, 0. The x-intercepts are pretty easy to find. You have the factored form. So you set each factor equal to 0, x equals 0, x minus 1 equals 0, and x plus 4 equals 0. So our x-intercepts are 0, 1, and negative 4. Going along with the factors would be the multiplicity. Any power that's not 1 is going to create a special sort of thing at the graph, on the graph rather, at that x-intercept. So the graph will behave a little bit differently if it has a power of more than 1. An even power bounces, so it looks like it's going to bounce at 1 and negative 4. If it had an odd power like a 3, not a 1, but an odd power that's not a 1, then it would slide. Let's go back to the end behavior. End behavior is tied directly to x to the 5th. If you don't know x to the 5th, that's fine. X to the 5th is the same as x to the 3rd, which I know you know that parent function. So you might need that little parent function to help you. End behavior is written the same every time. X approaches infinity, and then x approaches negative infinity. And then you just write down what y is doing. So this part will not change. All of this. It's the same every time. So as we go to the right, that means x is going up, so this is infinity. As the graph goes to the left, you can see this end is going down, so that's a negative infinity. It looks like we're ready to draw the graph real quick. It is a sketch. It is not a super precise graph. Start by putting all of your points on the graph. So we have a y-intercept of 0, 0. We have an x-intercept in that same spot, x-intercept at 1, and an x-intercept at negative 4. I just put that on there because I'm counting by ones. Apparently I don't need anything on the y-axis because I don't need any points going up or down. I know that according to my end behavior, this end will go up and this end will go down. It doesn't matter if you start on the right or the left, wherever you're comfortable or wherever you feel confident to place is a place to start. I'm going to start on the right. I know it's going to bounce at 1. So it's bouncing. It's got to, I don't know how high up it goes, but I know it has to come back down and go through here. And then I know it has to head back over this way and it has to bounce again, so looks something like that. This is just wiggly because my hand is wiggly, not because of any other reason. So be prepared to answer those 7 questions on the non-calculator part. Then the rest of this, you'll have your calculator for. In fact, the very first question, you'll have to have a calculator in order to do it, because it says directly, use your calculator to find as many roots as possible. So you go to y equals, type that in, then you go to the table, and then on the table, you look for where y equals 0. As many places as you can find. We know the degree is 3, so hopefully we get 3 of them. In this case, we don't. We just get negative 2 and 4. It is these 2 numbers that you're going to start with the synthetic division. So far we have 2 answers. We're looking for 1 more. I'm just going to start with negative 2. Coefficients, 2, negative 7, negative 10, and 24. Now we know this works, So you better make sure you get a 0 as your remainder. And then we'll multiply that. So then here we add. Remember, you add up and through here. So we get negative 11. Negative times negative is 22. Add that. So we get 12. This is negative 24. So that's a 0. And finally, we'll use the 4. Do not start over. Start where you left off. Because we're trying to just get this down, down, down. We're trying to make this a very small little polynomial. So 2. And then we get negative 8. How about... this is a positive 4. This would be helpful if I paid attention. So this is a positive 8. I thought this is going the wrong way. So that's a negative 3. 4 times negative 3 is negative 12, and we get a 0. 4 times 0 is 0, so we're still getting all these zeros. So now we have to figure out what we have. This started off as x to the third. Every time you go underneath the division line, x squared, go under the division line one more time, so it looks like we have 2x minus 3 equals 0. The question says to find the roots. So we have 2x equals 3, x equals 3 over 2, and of course we also have the negative 2 and the 4 from the calculator. Those are the roots. Now you will not have to multiply out a polynomial. You will, however, have to write out the factored form. So degree 3 means we need to have 3 sets of parentheses, and we do. And inside each one we'll put one of these factors. So if negative 3 is an answer, well, this would be x plus 3. If 2 is an answer, this is x minus 2. If you have a fraction, remember the letter, the x goes in the denominator, and you do the opposite of the numerator. So this is going to be 5x minus 4. You leave it like that. It says factored form. It doesn't equal 0. Just stop right there. This says degree 3, but we do not have 3 answers. So imaginary roots come in complex conjugate pairs. So if 2i is an answer, then negative 2i is also going to be an answer. So now we have x minus 4, x minus 2i, x plus 2i. Do not multiply this. Leave it alone. And then the rest of this whole quiz is factoring. And if you can't factor it, then use the quadratic formula. Anything goes. We've had all kinds of answers, integers, radicals, imaginaries, fractions, so anything can happen. So first thing we do is we get rid of this name, and we set it equal to 0. You could just start right into factoring. I guess that's unnecessary. In order to get x to the fourth, this would be x squared and x squared. 625 is a perfect square. So the square root of 625 is 25. Check that. If you have a perfect square, check on your calculator if the number is a perfect square, if you don't recognize it. But this is a 25 and a 25. Difference of two squares means there's a 0 in the middle, so one's negative, one's positive. Here we get x squared equals 25. X squared equals negative 25. When you take the square root, you get 2 answers every time, plus or minus 5. Now because this is negative, we're going to have an I. Square root of 25 is 5. It's negative underneath there, so we get the I. So there's 4 answers, just like the degree says. In number 13, we have a greatest common factor of x. You're going to have to take that out. You won't be able to factor it if you don't. We have x to the fourth minus 7x squared minus 44. And we factor this again. Now, if you were to put this in the calculator, it would look like it only has 3 answers. So be careful with trying to find another way. A lot of times the problems on the calculator won't all be there. So just in case you're trying that, x squared and x squared. 44. 1 times 44, 2 times 22, 4 times 11. There we go. 4 and 11. This will give you 7. So we're going to have a negative 11 and a positive 4. That'll give us negative 7. So we'll set these equal to 0. X equals 0. X squared plus 4 equals 0. x squared minus 11 equals 0. X squared equals negative 4. Take the square root. Square root means 2 answers. Square root, it's negative, so I. Over here we get x squared equals 11. X will then equal plus or minus square root of 11. So here's 4 answers. Here's the 5th answer. Anytime, every time you see 4, it's grouping. These do not have anything in common, as that 3 sort of messes it up. So nothing in common, no letters in common, so that means we're going to split this right down the middle. The first two, we group these together. They have x squared in common. You're left with 2x minus 3. Because that second group starts with a minus sign, you have to take that out. Now remember, we're trying to get to the 2. So if you think, well, how can I get to 2 with a 32? I can divide by 16. If you're not so sure about the 48, put it in the calculator. 48 divided by 16 also works. So this will give us 2x. Dividing by negative makes this a negative 3. Now they have a 2x minus 3 in common. And we're left with x squared minus 16. So 2x minus 3 equals 0. X squared minus 16 equals 0. So here we get x equals 3 over 2. And this one, of course, is x squared equals 16. And the square root of 16 is plus or minus 4. So we have all 3 answers. Again, the degree tells you how many answers you should have. For number 15, 4 terms again. Again, we split it up right down the middle. First 2 have an x squared in common, leaves you with 2x minus 1. The second 2 have a positive 4 in common, also leaving you with 2x. Now don't forget about the minus 1, because when you divide and they match, it is an answer. So we have 2x minus 1 that comes out, x squared plus 4. So this is 2x equals 1, so x is 1/2. And this is x squared equals negative 4. Now it's negative. Square root plus or minus, square root of 4 is 2, negative, so I. And this last one, multiply to get 11. One choice, 1 times 11. Not factorable. So you'll need the quadratic formula. I'll be expecting to see the work. If you have a quadratic formula problem on your test, I'll be expecting to see that you worked it out. Also, no decimal answers will be accepted, so please make a reduced radical. So we do the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So negative 3 plus or minus the square root, 3 squared is 9, minus 4 times 1 times 11. All of that is over 2. Now, if you want to put this in the calculator, I would think that's a good idea. Just this part, not the square root, because that'll give you a decimal, and we don't want that. So if you just put that in the calculator so that you can get a number, it's probably a good idea. But we have negative 3 plus or minus the square root of 9 minus 44. So underneath the radical is something negative. That is negative 35. 35 does not have a square root. There's no pairs of numbers in a 35. It's just 5 times 7, so we can't take anything out. So it's pretty easy to simplify because we can't. All we do is take out the I. You leave the radical 35, and the whole thing is over 2. Now this had a power of 2, so there's only 2 answers. And that's what you can expect for the quiz. It is a little bit shorter. There's not as many problems on the back, but the front is identical to what the test looks like in terms of length and types of questions.